Welcome to the media facility of the future, where your entire infrastructure rests on a programmable chip and you operate it through an app. Now, we're not quite there yet, but it is a plausible outcome of the direction that technology is taking today. Content development and consumption are evolving at such a rapid pace that we can see a time when physical facilities built around proprietary hardware and serial digital interface, or SDI, are no longer practical. Things like Ultra HD, high dynamic range, immersive sound, and 360-degree video require a lot of horsepower and a lot of bandwidth. The cost of upgrading physical facilities for these continually evolving demands is becoming prohibitive. Additionally, the primary consumption devices for video content are increasingly connected to the internet. This is driving a migration away from SDI and proprietary hardware toward IP-based technologies running on commercial off-the-shelf hardware and increasingly at data centers on and off premises, also known as the cloud. The promise of this technology is a type of operation that expands and contracts upon demand and has pay-as-you-go workflow functions, a type of elastic virtual media facility, if you will. We're still early into this SDI to IP migration, but it puts the media industry into the internet ecosystem. And we've come to the Bay Area to visit with two of its largest technology providers. We'll be speaking with two of their top technology experts, Intel's Vice President and General Manager of Network Platforms Group, Ms. Sandra Rivera, and Mr. Dave Ward, Chief Technology Officer of Cisco, about their company's combined vision of virtualization and what their joint initiative is bringing to the table for broadcasters. Okay, Dave, let's just throw down here. Let's just get going. What is Cisco's vision for the transition from serial digital interface to IP-based video transport technology?
Well, to be clear, we would like to provide all the transport that SDI currently is providing to the industry, from attaching acquisition devices, backhaul, use in studios, use in large data centers, or in media production facilities as they're known in that industry, and really provide all that underlying transport, and then also build this out as IP data centers, where it's a combination of networking, storage, and compute.
Is this a necessary evolution for the networks in general to be efficient enough to handle all of this escalating traffic, video, media traffic? Is it necessary to go that way?
It's absolutely necessary to do that in a cost-effective way. Historically, the network has been built on purpose-built, fixed function hardware appliances.
Big iron.
And big iron. And the big iron has done the job for which it was deployed actually quite well and effectively. The problem is that so much of that hardware is underutilized, because typically networks are over-provisioned for peak traffic, but not every single box in that delivery chain is used 100% of the time. So the idea behind network virtualization is that you're actually instantiating a lot of those capabilities in software as virtual machines running on a consistent platform architecture, which is really made up of standard off-the-shelf server solutions. And when you do that, then you're able to then share those compute, network, and storage resources underneath that physical infrastructure across a broad variety of applications and usage models, and you are able to get a much better asset utilization of that investment.
You can use automation and orchestration for the routing and connectivity of acquisition, the creation of workflows that are necessary in media production, and when you build it on top of IP data centers and having automated and orchestrated compute, network, and storage, you then can rapidly and flexibly change what that workflow is going to be as you need. When in the past, it would all be done by reconnecting cables, extremely manual and taking a very long period of time. Now, what had to be done was that traffic engineering, admission control as mentioned, security, quality of service, as well as flow awareness for those media flows was all built into that IP equipment, and that's what we've done over the last couple of years.
The big concern and for our constituency is their perception of network reliability. Do you get the 5 nines question, and how do you respond to that one?
Yeah, indeed. In fact, There is no conversation where anyone is willing to compromise on reliability or security, for that matter.
Right.
What we're moving to is not a lower bar in terms of security or reliability, but what we're moving to is a more innovative approach to how that's achieved. And how that's achieved in software as opposed to hardware, and how that's achieved at a system and a platform level as opposed to the big iron.
The difference between doing this in SDI network and an IP network is I can do this all with software. And I can do this all with push-button technology, while SDI, you were routing it with cables and believing that you were getting greater reliability because you were routing it with cables, when in fact, we can provide the exact same reliability with AB feeds and switch over between flows and channels, because we are completely flow aware inside the IP media data center to be able to provide that level of reliability and guaranteed routing of load across the network.
So again, these are media-centric networks. They're designed with media facilities in mind and what they do. And if the word isn't reliability, is it precision?
Built into, again, the IP data center and into our switching equipment is the ability to guarantee exactly where that load is going, build AB flows out of this such that you have multiple feeds coming in. You can guarantee maximum delay, you can have jitter bounds, you can have guaranteed flow isolation so that there's no multiplexing and overflowing of queues such as you get packet loss. And so it is the most precise and accurate mechanism orchestrated by software to have flow guarantees inside the IP data center.
Is there an immediate benefit that we can go and say broadcasters can achieve this immediately from this type of virtualized and next generation network technology?
So there's two very immediate benefits. One is on the total cost of ownership, both CapEx and OpEx. Because if you think about not over provisioning your network, because you're not buying the boxes and provisioning and deploying the boxes for peak traffic, but you're pooling the infrastructure, then clearly your actual CapEx outlay is much, much lower. The other big benefit is very much around service agility and the ability to deploy new services and new capabilities. And when you're deploying at the speed of software and not in terms of provisioning hardware, then you're able to bring new capabilities and services to your customers so much more quickly. And of course, that should translate into a revenue growth in the top line. So you're managing the bottom line in terms of your CapEx and OpEx and your TCO savings, but you're also growing the top line in terms of new services and the ability to deploy those services so much more quickly.
The really key piece of this when we talk about the elasticity or flexibility is that the equipment that you have, the compute, storage, and networking, can be flexibly rearranged into any workflow and modify that workflow, again, at the touch of a button or by programming exactly how you want that automation to occur. That's extremely different than very specific setups that are done for a very specific workload and workflow and cannot be and are not taken down or rearranged. And so if I'm doing a transcoding job, generally you have dedicated equipment just for that piece. And when you're not doing transcoding jobs, that equipment is sitting idle. And the expense of the inability to reuse the equipment, and I just used that one example, and there's many, many others, but the ability to then reuse that exact same equipment for a different workflow or a subsequent workflow in the media production is extremely powerful.
Well, it's interesting that you should say that because it also is happening concurrently with this sort of growth in consumption and certainly the move to mobile. And I think it's even Cisco's own research that says we may have passed the zettabyte threshold this year in terms of video moving across the network.
Actually, I think we passed the schlottobytes metric
I
on
don't
this.
even, yeah, okay. Fair enough, fair enough. But that's a piece of this too, isn't it? The consumption and demand of video over the internet, essentially, over IP technology.
Yeah, there appears to be just an insatiable demand for content. And that's fantastic for the entire industry. And that means there's just an unending demand for more and more internet, which is music to my ears. But that also means that the media and broadcast industry has to be producing content and new content and the ability to manipulate that content. Multiple encodings, et cetera, rise of AR and VR are also only going to add more bandwidth requirements, but also more demands on the media production and storytelling side of this as well. So I see massive growth in both of these industries occurring over the next, for the foreseeable future, to be honest.
Okay, tell us a little bit about Cisco and Intel teaming up to serve the media industry. What's the initiative there?
So Intel is a huge strategic partner of ours, and they are our CPU supplier in our ECS compute line. And in addition to that, we realized that we could solve a couple of problems together. Not only build great computers, we can build great data centers. And that required that we partnered up on not only how to build computers, how to build the I/O or NICs going in and out of those compute platforms, how they're attached to data center equipment, and then both work towards that goal that we both have as equipment suppliers for an automated and orchestrated IP data center. So we partnered building kit and products, we partnered in standards, and we partnered also in open source. And so straight up BFFs in this one.
I mean, clearly when it comes to media and consumption of media and production of media, Cisco has a huge role to play. Right. From an Intel perspective, I mean, we absolutely see ourselves as a key technology ingredient provider. Okay. And we see ourselves as an enabler of ecosystems. And we see ourselves as a company that is again powering the billions of connected devices as well as the data centers that that support those devices and those experiences on those devices. And as the world becomes more smart and connected, we feel like we have a critical role to play there.
Well, thank you for meeting with us today. We really appreciate it.
Thank you, Deb.
Thank you very much. All right, well, sir, that's all I have, and I thank you so much for your time.
You bet, anytime, thank you.
All right, I appreciate it.